Okay, I think we'll get going here on the third workshop um, that we are hosting for the month of March. And this workshop will be focused on the Tracer toolkit for Revit and Power BI. My name is Nate Miller. I'm the CEO and founder of Proving Ground. We're a digital design agency based in the United States that is really looking at how we can build tools, processes, and strategies for equipping designers and builders with data-driven capability. And in the case of Tracer, what we're really aiming to do is figure out a simple workflow for enabling designers and builders to make use of the data contained within their Revit files and visualize them and analyze that data within the context of business intelligence. So I'm going to go through a brief presentation deck here to sort of discuss the main components of Tracer. And I will then proceed and do a series of live demos. So if anyone has questions, feel free to use the question and answer section of the Zoom meeting, and we'll pause at different points to discuss questions up to that point. So what I thought I would do here is to maybe do a little bit of contextualization on what is Tracer, how does it work, what are the kind of components that you should be keeping in mind as a user of Tracer as you're working. And then as I go through the demo, I'm going to kind of try to articulate my thought process that I go through when I use these tools to present different data as well. And hopefully this is helpful in framing the toolkit. I thought it would be useful to start off with a definition of business intelligence and the significance of business intelligence in the space of building information modeling and all of the enterprise systems that may be used at any given point in time to collect data. Business intelligence refers to tools that provide historical, correlated, and predictive views of an organization's data resources. Tools like Power BI, Tableau, and a number of others out there allow users to connect into the various data sources in your organization and bring that data together. And then with tools like Power BI, you have this kind of interface that lets you drag and drop different visualizations like bar charts and pie charts, table views, and so on to build up a dashboard that can be shared with others, that can communicate the story that you're attempting to tell with your data and information. And it occurs to us as a group here at Proving Ground that Revit models, and I think more broadly building information models, provide organizations with a data set, a well-structured data set that can be used for analytical purposes. It's a kind of a cliche at various BIM oriented venues and conferences to talk about building information models as a database. And I think one of the challenges that we have as an industry is that a lot of these databases are often tied up into proprietary authoring platforms like Revit. And the way that we work as an industry often lends itself to working project to project, project by project, and producing this data, but never fully necessarily capturing or leveraging the data project to project. And so our hope is to establish workflows that can really help position building information modeling formats like Revit as a true database and data source, and allow users to connect to it as if it were a enterprise system or a project management system or things like that. So there are a couple of tenets that we're following with Tracer, some guideposts that's helping us think about BIM data in a way that can be useful and productive for many users. The first one is this idea that BIM should be a data source. We should be taking advantage of the models that we're making. We should be analyzing them. We should be looking for correlations and patterns within these models. And we should be able to correlate that information with other sources of data as well, within the context of running an architectural business or a construction business, right? We also think that you shouldn't need to be an expert to leverage BIM data. We think that a lot of the capabilities that are offered by business intelligence tools and tools like toolkits like Tracer that allow you to export and get to your data quickly, we really want to think about how BIM data and the use of that data can have a lower barrier to entry, and be positioned as a way and a capability that can be accessible to many, rather than the expert few. Now, that's not to say you're not going to have to learn new things or, grow your expertise over time, but kind of our aim is to really think about the democratization of data use in practice. And then there's this sort of idea that the data should be available for many stakeholders. So one of the things that I find interesting about the business intelligence paradigm is you can have people that are very seasoned and tuned in to the idea of data, producing dashboards and reports. And those reports and the availability of data can be accessed by people that may not be in that space of leveraging BIM or leveraging data. Maybe your CEO of your company can now access a dashboard that explains the data across several projects, or a market leader can start to understand and understand sort of the data that's underlying a lot of these capabilities. So, the aim of Tracer in particular is meant to kind of address these three things. It's not meant to necessarily be the complete solution to get to all of this, but we really wanted to think about Tracer as being this simple standalone toolkit that you can download and use with no infrastructure setup, and build on tools that you may already have on your desktop. So the way that Tracer works is that we have this idea of harvesting data from Revit. So you have this idea that you're in a Revit model, you're authoring new information, and you're having to harvest this information out. And what we're doing is we're pushing the information to a standalone, in the case of Tracer, a standalone SQLite database. It's a public domain relational database file format. And then that file format can be accessed by a business intelligence environment. So this is kind of the out-of-the-box workflow that Tracer provides. We've done quite a bit of consulting and development of systems that allow for the similar types of data to be pushed to other like database servers, and integrated with other systems, SQL Server, MySQL, and so on. Those typically require a lot of infrastructure and maybe even subscriptions to other kind of services. Tracer is really meant to be self-contained as a product. So just the idea of being able to simply get your data out and so on. So the components of Tracer is that there is an exporter. So there is a tool here that allows one to establish export presets, be selective about certain data points and element types in your model. And the idea is that this facilitates the migration of the data into a open database file that can be queried using conventional methods for how you might query a database. If you're interested in learning SQL, you can, which stands for Standard Query Language, you can use that. It's been around for ages to access the underlying data here, or you can connect it into Power BI and you access the various tables that Tracer provides that store this element information. And that's really where the kind of workflow that we're going to be demonstrating here surrounds the idea of getting the data out, making a direct connection into the database using a standard protocol that is available in Power BI called Open Database Connectivity. We're then streaming the information into the Power BI environment, at which point users can have a choice to share their reports, publish the information to the cloud, and so on. The experience that we're going for when it comes to building dashboards is really aimed to kind of mirror how one may use other components in Power BI. When you're in Power BI, you drag and drop the visual you want. You supply it with fields that you need. And so with Tracer, the idea is that you're able to activate one of our visual styles, a 2D visual that we provide and a 3D visual, and then dragging and dropping information from the fields list that's in this database will then activate the visual and allow you to display this information in different ways. So dragging and dropping the location values of a room into the visual will automatically generate the vector line drawing of those spaces in 2 dimensions and have there be the ability to sort of select and things like that. So we know that there's like workflows out there for doing things like this with, curating SVGs and so on. This is automatic from the data fields that we're providing. And I think this kind of opens up kind of a bit of a conversation about the role of geometry in the kind of the data world. We're kind of treating geometric records that are stored in fields as a source of data. And, you should be able to render a geometric component as easily as you would render a numeric component or a text component out of a field. It's kind of the philosophy we're going for here. And this kind of concept allows us to pretty rapidly develop some interesting dashboards that can serve use cases. At Proving Ground, we're very much around about the idea of use cases and user stories. What is the data that you're collecting going to be doing in your dashboard? How are you going to be communicating it? Very rarely do we ever do complete data harvests of models. We often have a story in mind. This is a dashboard that uses our 2-dimensional visual to show the idea of reporting space information about a office property where you have different suites, different sizes of office suites in a building. You have shared amenities, you have occupancy information. And the idea is that the tracer visual here is being used as a way to communicate some of this information about different available spaces. And then other information stored in the Revit model is being presented through pie charts and bar charts and tables to communicate the kind of underlying data properties of these elements. We also have this kind of component for using the same data source in a 3-dimensional context. So here we have a visual in Power BI that has a very similar principle. But instead of rendering 2-dimensional location data, we are in effect now producing mesh information in 3 dimensions. So here we are dragging and dropping the mesh field from the database that we're producing. And as a result, we're then rendering the different fields. We're able to override and assign kind of data values to the objects. So you can override color and start to create these, I guess, diagrams of the building. And this kind of has some interesting use cases in terms of the information that we're collecting out of these models. This is a mock-up I did a couple of days ago that looked at, hey, if we're grabbing information out of a file and we're grabbing the geometry about the different elements and instances, can we kind of create and use Power BI almost as a family viewer or family browser? And what you kind of see here is the rendered mesh objects that are stored in the family library in Revit, but now pushed up into the data environment and displayed in the context of a family browser. So we're kind of doing stuff with pagination. We can, display multiple families at once and, kind of almost do a bit of an audit of a family library in any given model. So, I think one of the potentials here is to then think about other stories that you may have. You may have an interest in communicating certain element types to a stakeholder. Maybe it's rooms, maybe it's spaces, and you're looking to show availability of spaces and track program and planning information as you go through a design process. Maybe it's understanding the different components related to the structure of a building, and you're looking to communicate the structural design in some way through a dashboard that can be shared with others. or even mechanical systems. And what you'll note about this particular video case is that the these are being hosted on the cloud. So we're publishing these dashboards directly to Power BI, Power BI's cloud, so they can be shared with other people. So these are public links, and I'll show you a resource where you can access some of our previously saved visuals. So what I thought I would do is maybe go into more detail at this point and talk a bit about how the workflow happens in the context of Revit, and demonstrate getting data out, and maybe talk about some of the opportunities, but also look at some of the limitations of the tool. And Power BI does have limitations, and I think it's kind of important to recognize those and kind of talk about, what are the workarounds, and how do you start to really position this methodology in a different way. I also kind of wanted to note that we're offering a pretty standalone self-contained workflow here. It's not necessarily going to satisfy all use cases, but it certainly has what we think is a low barrier to entry in getting into this, and it doesn't require other infrastructure. We've seen other viewers in Power BI that leverage like the BIM 360 model viewer and other subscription services. This is a kind of perpetual licensed standalone tool. So I have a Revit model here with a number of different components. This was initially developed as a training model back in the days when I was doing some degree of Revit training and also teaching digital design courses at university. This building should look familiar to fans of modern architectural history. This is a not an exact replication, but a reproduction, I guess, of the Seagram's building by Mies van der Rohe. So there's some classic Mies van der Rohe details in this project, and it used some of the plans that I was able to find online to kind of derive the overall size and shape and resolve it. You can kind of see like there is a classic Miesian detail here. If I can maybe even go to the hidden line mode, we can start to see that you've got that kind of I-beam, kind of mullion cross-section operating here. I can sometimes, even to this day, I can still geek out about little architectural details like that, that I think are kind of fun and important. But what I thought I would do is kind of use this as a basis to tell this, maybe tell a story of how one might use Tracer in this context. So this is a Revit file. And what you'll see is that I have when Tracer is installed, you'll have a Proving Ground tab in Revit, and that there is a Tracer 3D add-in here that you can access. And what this add-in does is it allows you to harvest your information out. And you can see here we have an update available to Tracer. You'll sometimes get notifications like that when you run the tool. But what you're going to see here is an interface that's going to open up that gives us some export preset options. And we're going to see here that we have a couple of presets that are available out of the box. You can create your own, and these presets refer to export options that you may check and select inside of the Tracer environment, right? So you have a couple of options. You can choose to export objects with two-dimensional kind of diagrammatic information. You can also choose to export the mesh information for every object in your model. There are some compression settings, and this gets to the idea of really helping the user, I guess, get data to a point that Power BI can start to recognize. There is a kind of an interesting set of limitations with how much data can be stored in a single field that Power BI will not automatically truncate behind the scenes. I'm going to show a workaround for some of that in this discussion. We've also found that a lot of Revit files, whether you realize it or not, have some pretty large meshes attached to different components and objects. They're in my kind of past experience, auditing BIM files, you'll find that a lot of models have over modeled shapes where I found one recently. It was like it was part of a retail store where every single wire that would go into like a product rack was being modeled. So you had this extremely elaborate cage model, almost looked like you could send it out to fabrication. But there are so, large objects that can end up in these models. And so we have ways of kind of saying, if you encounter an extremely large mesh, we can save some time and, get to some maybe bounding box level representation, for example. You'll also find that a Revit file has a bunch of stuff in it that you may not ever need in your workflow. And we wanted to provide a way for users to be selective about the data that they're exporting. So for example, these are the Revit categories that you could choose to select. And if you sort by count, you'll see that, there are a number of objects here. You can see this particular model is dominated by curtain wall mullions and curtain panels, primarily because of the attention to the exterior facade here. There's also a number of walls. You can see that there are specialty equipment categories being used here. Model group information, stair and riser information. There's stuff in here that, let's see if I can find a good one that you may never ever be interested in getting to. There's like work plane grids that are listed and available here. So there's stuff in the model, and I think in our workflow often involves being very selective about what we're trying to do in the story that we're trying to tell. Unless we're doing a complete model evaluation, like an analysis of family content, auditing for standards compliance and things like that, very rarely do we ever do a full model push to Power BI. We tend to be a bit more selective about this. And so what I'm going to do is maybe get to a specific use case with this. And inside of this model, there is a floor plan that I like to use just to kind of show a variety of different element types in the model. So here's a view of the Revit model. It's in a large floor plan. You can see that we have a room layout, doors, walls, dimensions. You can see the perimeter of the curtain wall and curtain system here. And what I'm going to do is I want to build up a dashboard around maybe this particular view. For one, it will help save some time in this workshop to get a model out quickly, and also kind of show how we're kind of limiting the scope of an export to get to maybe some particular data that we want. So I'm going to go ahead and launch the tracer add-in here, and I'm going to do a couple of changes to the settings here. So one thing I'm going to do is I do want to export 2D and 3D. If I have these unchecked, it will still export element records for every object, but you're only ever going to be able to see the kind of data record, like in itemized element list with their parameters. So there are use cases for using a tracer that don't even involve geometry. In this case, I am going to export both. I am also going to uncheck bounding box for large meshes. I want to get everything out of here. Under Revit categories, I want to limit my export to just the objects I see in my active view. This is something we introduced really in the last week, the idea that we can filter the exported elements to just the active view. So we're kind of, again, narrowing the scope of data that we're looking to export. And you can see here that this is, bringing the total of information down to, you can see curtain wall mullions, 328, curtain panels, rooms, we're getting all the room objects. And there's stuff in here that I may not even really be interested in, to be honest. I'm going to kind of get rid of the top rails here. I don't really need cameras or reference planes. We've got kind of a stair representation here. This stair is multi-story. I'm going to go ahead and uncheck that for right now. And we can talk a little bit about what it would mean to add that in. It's a high resolution object too, because you have, all the guardrails and, tread details and stuff like that on it. So I'm kind of, creating a kind of a more narrow scope here of information. And I'm going to go ahead and click export. And you can see I have on my desktop here a couple of databases already kind of prepared. But what I'm going to do is go ahead and do a kind of workshop level 12. And I'm going to go ahead and save that out. And then Tracer is going to go then through a process of exporting these elements. Export times are going to vary quite a bit depending on your model. If it encounters some high poly meshes, those take longer to process. I did a test earlier this week on elements, 35,000 elements, but because the elements were kind of reasonably sized, the export went really fast. And I've done exports where there may only be 2,000 elements, but it hits one of those high poly meshes. And so we have to go into some additional processing, because what we're doing is, creating a record that needs to be then inserted into the database field. So there's oftentimes there's some post-processing information here. So what you can see that we have is that after Tracer completes, we have this database created. This is, again, the level 12 view that I have active for the workshop here. And there are a couple of ways that one can go about now exploring this data. Power BI is one of them, but I do want to highlight maybe a tool that we found to be kind of an interesting and useful companion to Power BI, and that's the free open source DB browser tool. DB browser allows one to connect to an SQLite database and look at the table structure and do some interesting things in this context. You can execute SQL commands. I like to bring this interface up just to kind of show a little bit about the data that has been harvested. It's a good way to do a review of that information. So I'm going to go ahead and go to my desktop here and find that project. And this may be very kind of techie and in the weeds for some, but it's, I think, still a useful exercise to look at. The key tables that Tracer exports, you'll see that there are a lot of tables here that involve SQLite support for geometry objects and things like that. The important stuff involves your document parameters, element records, element parameter, integer parameters, numerical parameters, Revit IDs, and text. So basically the hierarchy is that we're getting an element record list, and then that we have a relationship to a table of parameters that relate to each element. So we can say, okay, I have this room element, show me all the numeric parameters for that room element. So that's the kind of core schema that we're working with here. We also have views for the information that allow for quick access to certain element types. So in the database world, you have tables which kind of store your data, but you also then have views of that information, which might be a summarized list of all of your wall elements, or a summarized list of all of your room objects here. So to give you an idea of how this might work is if I right click and I browse the element table, this is going to give me a listing of all of the elements that are in the information. Some elements have geometric information, some do not, depending on the element type. So for example, here are some walls where you can see that we're getting the location data as a GeoJSON string, and then we're also capturing the mesh information for that object as GLTF. So these are some data fields that are kind of storing information about each object. So we're now getting that information being pulled over. And that's kind of in contrast to if I were to go to my views here, if I wanted to say, okay, well, show me a summarized table of all of my object views for rooms. So this is now a rooms table where I can get all the information about a room object that's stored in my kind of element library. And I'm getting my kind of numerical information about these rooms, as well as like some text information that's being pulled from those room instances. And then we also have, location data for the rooms in 2 dimensions as well as 3-dimensional meshes. So this is all in a SQLite database format. So you may not even need to know any of that. That's context, because where this becomes important is how we get into Power BI and how we can start to use and manipulate this information from a business intelligence context. Before I jump into this, maybe we can look at a few questions that are coming through the chat. So Steve, if you would be so kind to maybe...
Sure, yeah. So one thing that you kind of touched on, Joe asked the question, have you identified any limits to the geometry previews, maximum file size, or some other measure like mesh or vertex count?
Yes, so we're going to cover that in a little bit in this exercise here with Power BI, because there can be moments where you have to wrangle information. So Power BI, when it comes to information loaded from a query into a report, there is like a character limit. And that character limit, I believe, is 36,000 characters of text that can be loaded into a report at any given point in time. I believe this is a Power Query limit. But what you can do is do a little bit of data wrangling ahead of time before you load it in to bring that character limit to a reasonable volume and then concatenate certain fields in order to get the full mesh. So there are some workarounds there. We have found meshes that produce GLTF files that are crazy large. I think we encountered one, a Revit family in one of the projects that we were working with recently that produced a GLTF that was something in the realm of 50 million characters long. It was a pretty crazy mesh size for just one object, and it had to do with over modeling and probably the author of the file not really considering a use case beyond its placement in a Revit file. So there are those sort of things to look for. I'll kind of go through that a little bit here.
There were a couple other questions that I think would be helpful as we continue into Power BI. Alexandros asked if we store custom user shared parameters in the database as well.
Yes. So if the object, so a good rule of thumb is that if an object has a parameter that can appear in a schedule, or if it's appearing in your properties window in Revit, if you click on the object, then that should come over in the form of a data property. Yes.
And someone else asks, what's the most reliable unique identifier for objects that remain static between different sessions of the file?
Good question. So there are several identifiers that are available. Revit has an element ID. You can actually search objects in your Revit file using the Revit element ID. There is even another identifier that is more unique than that called basically a unique ID. It's a GUID formatted ID, which we also capture. And then when we create our database, we also introduce a tracer created ID for an element. These are integers, and they're aimed to be kind of an efficient way of managing data apart from Revit's kind of schema. And so a lot of our relationships between tables uses that identifier.
Okay, and then Alberto asked if Tracer only exports your current view.
No, in fact, I'll go back. What I did for the purposes of my demonstration here is that you have the option to kind of export your current view. You can do your entire model. And again, very rarely do we see people that do their entire model. And we're a big advocate for kind of knowing what data you may need for your particular user story or use case. So you can do it by view. There are some use cases for where a view-based export will help you kind of just get to some information that you need to present. You can also do just elements. So if you had a very large project, but you're like, I only need the rooms and I need the floor plates, that's also another approach that you can do, is kind of say, across this entire model, give me all rooms and floor plates, or things like that.
One last question, Nate, then I think you can keep moving on. Two people asked about an approach for IFC, ArchiCAD models,
Yep.
other open source BIM software.
Yeah, so that's a great question. At this point, Tracer is a Revit and Power BI toolkit. So we haven't created an IFC viewer, although we have tentative plans and have talked internally about creating an IFC style viewer that does a similar kind of level of integration that our Tracer toolkit and Semantic, which we did a workshop on last week, does, which is kind of display three-dimensional information. We're primarily a North American-based company, and so what we find broadly in our kind of main market is that Revit is the sort of tool that most people are using for production purposes in the BIM context, and we haven't seen in our marketplace much use of ArchiCAD or and I think, unfortunately, much use of IFC. We've done a bit of work with IFC in other contexts, but it's still very rare to see people making use of it in a robust archival manner. Although, like I said, we are working towards migrating a lot of these concepts over into thinking about how an IFC viewer may come together.
There's one more, I think. Three people just asked this. What about extracting data from links?
So linked models is one of those things that, our toolkit is supporting the open document, and harvesting information from links would require separate exports of those links. Under the Tracer paradigm, at Proving Ground, we have developed a server-based way of harvesting information, but that's more of an enterprise system. It requires us to establish ways with which we can, send, say, 3 models at once to a harvesting node and allow it to work through those 3 models. But it's not really well tuned to a kind of a standalone, I'm a user on a desktop, I downloaded this add-in and I need to get to my Revit files. So there's a lot of, things to consider there. So Tracer is really framed around, just being that standalone toolkit. If you're interested in that type of kind of more comprehensive harvesting across multiple files, across multiple links, and we're more than happy to talk to you about what that infrastructure looks like. Sure, and to build on that kind of touches on a couple of the questions I have here in terms of automated and periodic exports. There's, to Nate's point, other tools that would be more poised to grow to have that capability. So the Tracer add-in that we have on our App Store cannot do automated exports, but certainly that's something we have some thoughts on if you want to reach out. Sure. I'm going to keep moving on because we have limited time and we haven't even touched Power BI yet. So feel free, Steve, to enter in answers in the chat and clear out some of the questions as we go. Or if people hear new information, more than happy to hopefully this my demo here will answer some of those questions. So I'm going to go ahead and get data. So I'm in Power BI, and the way that you connect to a data source, any data source, is that you're going to get data from some location. So here in Power BI are the number of data sources that are exposed, right? So I can get information from an Excel file, CSV file, XML file. I can attach to an Access database, MySQL database, SQL Server. These are database servers out there that you may have in your organization. The Tracer database as a standalone SQLite database can be connected to using ODBC. It's a standard open database connection protocol. And if I connect to this, what you're going to do is be prompted with a visual here or an interface here for, okay, you're in an ODBC data source. We're using the SQLite 3 data source. So you would set your data source name to SQLite 3 data source, and then we need to tell it which database to connect to. And what I'm going to do is go to simply enter in a simple connection string. Connection strings can get pretty onerous in the database world, but luckily we're in a very simple context here that I can simply say, okay, well, let's grab the file path to this database that we just harvested and paste that in. I'm removing the quotes from my copy and paste there. That's kind of key. But this is going to make a connection into that database environment. It's going to then present us with an interface here. There is no credentials. We're not logging into a database server, so I can simply hit connect here. No permissions on the file, although if you wanted to add password protection and credentials, you probably could. And what you're then going to be presented with is a listing of all the available tables and views in your database. So what I thought I would do at first would be to maybe give you an idea of how one might work with the database schema. So I'm going to go ahead and select my element records. I'm going to select my parameters for integer, number, Revit ID, and text. So this is going to give me like my element listing. So every element is going to have parameters, and we're going to see how this sets out a relationship in our model. So I'm going to go ahead and load those in. And Power BI is then going to make a connection into this database and start to bring that data across and identify the relationships between these tables. So this is, I guess, the core database structure that I'm accessing at this point. And depending on your database size, there may be this may take a bit. Here we're working with a rather small, limited database size, so it's not that big of a deal here. But now that I've loaded it in, you'll see that we have available fields of information. We have element parameters, and things like that. And if I go to my data browser, what we're going to see is this information presented to us in a tabular way. We can see the different records being pulled over and being pulled across. We also have this relationship view of our information. And this is where you can really start to see the hierarchy. If you're attaching into any given database, you can start to see the hierarchy of the information. So you're going to see that Power BI has detected some automatic one-directional joins between the element table and the associated parameters. This allows us to do a one-to-many connection between any given element and the associated parameters on another file. So there's a kind of relational component there. But what this allows us to do, if we were to kind of put this into action, is it allows us to start to understand different aspects of this data in the Power BI environment. So for example, if I wanted to understand how many elements by category do I have, I'm going to activate this bar chart. And what I'm going to do is then think about, okay, there are these inputs that I need to insert to create this bar chart. So I'm going to say, okay, well, I want my axis to be category. So that's going to be all the different categories I exported. And then maybe I want to count by the type of element here. So what I might do is say, like, you know what, maybe I'll use the Revit unique ID as my value. So it's going to count up how many elements I have per category in my model. So just as a basis of demonstration, this is a Power BI visual that has some now data assigned from this database. But we can do a lot more than this. We can start to then say, okay, well, what about the geometry? What about some of the information related to our model? And what we do is we are able to say, with Tracer installed, you're able to import our custom visuals that we ship with Tracer. So if I choose import a visual from a file, I can navigate to my documents location under Proving Ground and Tracer, and you can see that you'll have access to a visual, Tracer visual, which is the 2D version. And there's also the 3D version. And if I grab the 3D version, you're going to see that that's going to load in some information for us here. That's going to be a new visual type here in 3D. And if I go to import visual from a file again, you can see that we can get the 2D visual. So we now have two-dimensional visual type loaded as well. So you have these as ways of viewing the information, right? So What I'm going to do is maybe just do a quick view of the 2D stuff to start. So here's my 2D visual I've just activated, and similar to this bar chart over here, it's got some fields I need to satisfy. And what the 2D visual is looking for in this case is some location data that's based around the GeoJSON format. So you can see that we expose in our elements table this GeoJSON field, and I can drop that geometry in. And what you'll see is that it is going to pull in all of the location data that these different elements possess in the given model, and kind of communicate this. So what you're going to see is, like, you're going to see this these fields here articulating the kind of room boundaries. You're going to see center lines representing walls. You're going to see object placement points in this view. But what we can do is start to work this visual over a little bit and get it to a point where, it's communicating something kind of more meaningful than just a dump of location information, right? There is a kind of an interface here that you need to be aware of when it comes to your geometry, is that if I drop I might need to satisfy this field here called location GeoJSON. This is a kind of a workaround for some interesting things that we're doing relative to Power BI's data structure, and that we need to supply some summarized information about our objects so that this can respond to color highlighting across. So if I wanted to select my walls, for example, over in this pie chart, it's now highlighting my wall objects only in this view. And if I want to show my rooms, it's going to show that information. Or maybe let's see if I have a floor object in here. Curtain walls, for example. What I want to do here is create a couple of filters on this so I can just show some information that I'm interested in. So I'm going to go ahead and go to my category tab, and I'm going to take the category tab over into my filter. And you can see that it's now exposed a filter where I can say, okay, well, I just want to show one type of object or another, and it's going to filter everything else out. So I'm going to say I want this to just be about rooms for the time being. So now we've got all of our rooms itemized here, and we can see those displayed for us in this kind of format. What I can also do is start to establish relationships with some other properties. So we have, for example, these rooms, and let's say I want to color code these rooms by a given name, for example, or a piece of department information. So what we can do is start using the relational structure between elements and parameters to really drive this type of exploration. And what I'm going to do here is, look at my element parameter text field, and you can see that we have our text-based parameters exposed. This is where you're going to get information like room name and room number and room department and things like that. So what I want to do is I want to get my numerical or I guess my text-based information for my room name, so I can color code everything by name here. So what I'm going to do is I'm going to take the name field. This is the name of the parameter that I'm wanting to grab, and I'm going to pull this over to my filters. And you can see that we can get access to some of the text-based information in our object. In this case, I want my room name. And then I'm going to take the value and supply that in for category. And what that's going to do is it's going to override the color of this plan to now assign colors based on the room name. And, these are default Power BI color selections. So, it's kind of ghastly, to be honest, when it comes to like Microsoft standard color suites. But what we can do here is now start to do a little bit of wrangling of the visual style. So under this chart, we can go in and we can start to get into all sorts of different color styling overrides. So maybe I can say, okay, for my data colors, maybe I want my, let's see, conference rooms to be, a different shade of, color there. Maybe I want my executive, see if I can find my core here, or some of my elevator banks. Here we go. elevators to be maybe a darker gray or a gray color. I may do some of those colored overrides there. And you can go through and just basically curate your color list. There's also a nice feature that we have here for color input. If you have a table of standard colors for these different spaces, say it's a color key by name, and you brought that into Power BI as a field, you could use that as an input. So what I'm going to do is also activate my labels. So I can turn the labels on and see the information about each of those capabilities there, and each of those itemized room lists, and have those sorted. I can choose to turn the background on and off. I can change the color of the text itself, for example. So I have now sliced up my imported data to reflect a certain view of information here, right? What I can also do is start to think about the three-dimensional side of this. And this is pretty exciting when it comes to what we can start to visualize with just a three-dimensional widget. And it's a very similar workflow. We have a widget here that is set to view things in 3 dimensions. And under elements, you can see that we have this field called mesh. And what mesh allows us to do is pull over our mesh-based information, and it will then display our information in 3D, and you kind of see that it defaults to this kind of gray tone overlay of information. All the colors are kind of clay modeled here, and it's giving us everything that's in our database at the moment. So we're seeing our room volumes overlaid on top of kind of mullions and things like that. We can see that we've got individual mullions as well. And yeah, we're pulling that information over. But what we can also do here is start to also create some filters on it and start to do some overlays of and demonstrate some different visualization styles. So what I'm going to do here is start to just go through a process of doing some similar filtering. What I'm going to do is bring my category over into my filter and say, well, maybe I have my rooms displayed in 2D here. Maybe I don't need to see them in 3 dimensions. So I'm going to go ahead and do a select all. And then I'm going to search for my rooms, and I'm going to uncheck those. And so what you're then going to see is this over, all the objects except the rooms being displayed here in the model. We can also start to do some studies of maybe overriding color by the different categories as well. So if I say, well, let's color this 3-dimensional model and show me the differences in category, I can drag that over into my input field, and it's going to show the color code each of our objects here, which of course we can continue to override and display as well. So if I wanted to change up the visualization style here, I can go to my Format tab, and I can go through this process of understanding some of the different rendering options. So right now I'm in a perspective mode. Let's say I wanted this to be orthographic. This will then change it to kind of an orthographic style of mode. I can go to, say, a flat shaded mode, which is going to remove the shading gradient on it. So it kind of has a bit more of a cartoon-like appearance, I guess. I can change the edge color of my objects. So if I wanted to be kind of white edges, for whatever reason, you can, do that type of rendering style as well. So, it's all about, I guess, changing and styling the appearance to be something that you feel best communicates your idea. There are other kind of styles here that I think are kind of interesting to look at when it comes to, say, for example, data colors. Like with the rooms, I can start to override different bits of information that are being displayed here. So maybe I want my columns to be white in the view, which will make them white. Maybe I want to take that down a notch, make them gray, so they kind of appear against the white edges a little bit better. I can go through and change up my maybe the look of my doors to where maybe those are kind of more of a that color there. You can obviously tweak these to your heart's content. There's also a couple of different modes of visual style here for color override that apply to the the 2D visual as well. So right now everything's category based. If I wanted to do it kind of more of a gradient style where show me a set of extremes, this works really well with numeric data, I think. But if you wanted to start with elements going from white and transitioning to another shade of color, you can start to set that up here, and it'll start to kind of communicate that. I was kind of messing with this the other day, and I was getting to almost some Peter Eisenman looking diagrams when it came to just some of the visual styles you can achieve. I'll go back to black edge colors. Soften that up. I could get really tied up in this, studying this if I wanted to. There are also like some other things that we can do here. I mean, there's views. That's one thing I really wanted to talk about here with the three-dimensional visual, is that we can start to say like, okay, well, right now we're displaying everything in a single panel. But let's say I wanted to create a diagram that understood the breakdown of systems in some way. So if I would jump back over into my editor here for fields, I can see everything's being represented in the same viewport. But what if I wanted my objects to be listed in separate viewports by some categorical information? So what I'll do here is bring my category over to the View tab. And what it's going to do is it's going to parse each of those element categories into their own kind of view components. So now we have kind of all walls existing in kind of their own viewport, all curtain systems, all doors, and so on. And under the styles, or under one of these, I guess, format settings, I can say, okay, well, right now it's showing there's a maximum of 30 viewports that it'll display at once. But if I wanted this to just be one, it'll take us back to a single view. So there are my columns. There are my curtain wall panels. There are my mullions. There's my doors, and so on. So I can start to really parse the information in these models in some of these ways, which we think are, it's pretty exciting to consider some of the possibilities for. Design options may be another way to kind of think about parsing this. So if you have a layout, that's one option. Maybe you set your views to be based on design option as a possibility. I did want to touch on meshes for a brief moment as well, and talk a little bit about the some maybe exporting another selection of the same building. So I'm going to do that really quickly. I think if I jump over into my 3D view here, I'm going to export just my floors and my columns for this entire project. So this view has everything, right? If I go back into Tracer here, I'm going to go ahead and uncheck Filter to Active View, which is going to give me everything in my model. I'm then going to say, you know what, I'm going to select none. And what I want to do is find my floors. I'm going to export my floor objects. And then I'm also then going to find my columns. And you can see I've got 82 columns there. I'm going to select that. And so now I'm just selecting kind of a subset of the geometry in my model. And what I can then do is say, okay, let's export all of that. And I'm going to go ahead and go to View. I'm going to go here and just say Columns, Floors. And I'll save that out. So I'm saving another kind of iteration of this database that, again, is isolating some components I'm most interested in. I'll let that export finish. And while this one is going, I know that we're hitting right up at the hour here, but are there any kind of questions that we can pull out from this?
Yeah. So there was a question about instance and type parameters on elements. It looked like, Nate, there's some predefined views about rooms, for example, but those element parameter text tables and the others, do those house the instance and type parameters?
Yes and no. So there is a kind of a nuance here to understand when it comes to how parameters exist across type and instance. So maybe what I'll do here is just maybe show how that plays out practically. So what I'm going to do is I'm going to go to my recent data sources here. This is the database I'd connected into earlier. And maybe what I'll do is pull over just my room elements. So as I mentioned before, I pulled over my entire itemized list of elements and parameters. There are these views that might be really helpful to kind of create summarized lists. If I just want my elements for rooms, I can just pull those over as a table. I can also go over and say, let's see if I have any family instances. I don't think this model has any family. Oh yeah, there they are. Family instance elements here. In this case, I didn't export because I was doing a view-based export. I wasn't grabbing any family symbols, so I might demonstrate that here in just a second with that. But for example, if I wanted to just load in my room elements, I'm going to go ahead and pull those in. And it's going to make a connection in and query my database and bring over a new field set for just room elements. And this is where, this makes working with rooms really easy. It's one of our primary use cases, I think, for Tracer. Okay, cool. So I'm going to jump over here and say, okay, well, with this Tracer 2D visual, instead of drawing from my elements and parameter lists here, I can activate a single table that just has all of my rooms. And all of my rooms with their parameter set, including any user-defined parameter that you may have on a room would be listed here. But for example, if I say, okay, let's grab my element location, drag it to geometry, I now have my listing of objects. And let's say in this case, I want to visualize it by department. So there's my department information for that room. And it's now color coding my plan based on that. But maybe department isn't the one I want. Maybe I want to do it by room name. That gives me my room name. Or maybe even something even more granular like the area, for example. And now every unique area in the space is being assigned its own color. So those view tables are really helpful for quickly getting to some specific information. What I want to demonstrate now is maybe quickly getting into the, I think this object that since I exported columns, had some information here. Still building the file, it seems. But maybe what I can do is jump to another data set that I know I had pre-set up for this. Here's a familiar project. So here we have another model. This is the advanced sample model that comes with every kind of install of Revit, and it's done a complete export of all objects here. So what you're seeing is a listing of things like, okay, well, you have family instances. Let's see if I can find my family instances. So I have my family instance elements. And my family instance elements have itemized records of every instance of a family and the instance parameters for every family. But then there's also this other table here called family symbol elements. And family symbols are essentially your family library inside any given Revit file, right? So your family symbols allow you to access like, okay, the type properties of a door or the base geometry of a door before it's placed in the model. So it's kind of reflective of how Revit kind of handles the distinction between type and instance. And these two things can be related to each other as well. So you can join, for example, your instances to your family symbol data, and then you kind of get your entire record of both instance and type parameter being shared. That actually might make it for a future video tutorial to kind of discuss some of those underlying relational characteristics of this database.
And that's all how Revit organizes the information in its sort of environment. So we're kind of having to reverse engineer that in a way.
Yeah, and yeah, produce it in a way that is reflective of the kind of the data scheme of Revit inside of this relational database environment.
Do you want some other questions, Nate, or do you want to keep pushing through on some Power BI stuff?
Yeah, I mean, we can Well, maybe what I'll do is I'll kind of maybe work here and bring some data in, if I can.
Sure. So
yeah, why don't we keep going? Why don't we keep going through questions? That might be the most useful thing. It's because
Sure.
what I can always do is follow up with a couple of video tutorials on things I didn't get to in this session.
Sure.
Such as meshes and kind of wrangling meshes and things like that.
Can you visualize grids in the 2D viewer or the 3D viewer?
That's a good question. It should. And if it doesn't, then we need to add that in. I think, let's see if I can jump over here. It doesn't look like, I think I have this view filtered here. So let me just, oh, a quick way to find out.
Grid line, there they are. Huh.
That's a curtain wall grids.
Oh, I see curtain wall grids, yeah.
Grids. It's all alphabetized, maybe. Ah, a flaw. We should be getting grids. So we'll probably have a service release up there for grids. So the answer to that is not right now, but maybe in the next day or so.
Cool. When you are adding the data sources, the variety of views and tables from the SQLite file, does Power BI understand the data relationships in the model? Does that happen automatically, or are there instances where you'll need to edit the model on those data relationships?
Can you explain that again?
So when you do the SQLite import, do the data relationships between the tables get generated automatically in Power BI, or are there instances where you need to define those? If you look at your model tab on the very left, below data, and one more down.
Oh yeah. So yeah, I did cover this earlier, I guess to some extent. But here, what we do is with this base structure, we are it is a relational database. So the base relationships that we're capturing across these fields are, there's a document table as well. Document element has documents, an element has parameters, and so that relational schema is joined up using our ID and primary keys. You can establish relationships between tables in other ways if you wanted to. So for example, I have these Revit, different IDs, like a shared unique ID, or as I was indicating before, maybe I'll continue that exercise here where I pull in different element parameters. Let's see, I'll jump back over here. Yeah, so for example, you can join the element, the family instance and family symbols on a family Revit ID, for example. That's not an inherent relationship in our database, but because we're using an ID-based structure, you can, kind of sync up, different tables together so they interact. Because we are over time, I did want to conclude at least by highlighting some resources that are available for learning more about Tracer, and where you can expect to see future video tutorials and other announcements being made. This is our main website, apps.provingground.io. We have 3 products. This is the last product that we're covering for March, which is an overview of Tracer and some of the things it can do, give an idea of the workflow in kind of a live demonstration setting. If I go here, you can find that we have example information about what it does. But what I think people will be really interested in is the documentation. This includes step-by-step guides on how you can go from your Revit model into Power BI. We have numerous video tutorials covering different subjects related to how you can harvest data and access some of the information, build up different dashboards. We do have 2D and 3D dashboard examples. So for example, if you go to the 2D section, you'll see that we have a couple of reports published that you can open up. So this is one of the reports I showed in my presentation earlier. It'll take you to a live cloud published Power BI report that was made using the tracer tools in Power BI. So this is sort of that plan diagram I was showing before. There are also templates that you can download. So if you go here, you can download these templates for free. They're kind of prepackaged Power BI files that you can simply point to your data source and it'll load up your information. These templates do include the demo visual, obviously not the licensed visual because we're providing these out there for free. But you can always swap out the visual that comes with the trial version, which has this kind of watermark on it, with a fully licensed visual. So you're able to kind of go in and re-import your visual and it'll update it once you have a licensed version. So hopefully these resources can provide you with a good starting point for getting started and not have to go through the entire setup process like I was showing you here. This could give you just maybe a step in the right direction if you're just learning Power BI and you're wanting to learn how these things can interconnect. But I also do recommend checking out these dashboard examples because they do kind of highlight capability in your browser and will let you start to understand how these visuals can play a role in sharing your information using this kind of self-contained standalone toolkit that we're providing.
Well, I've been noting to folks about using a Power BI Pro license to be able to manage the access to dashboards. If you have a free Power BI account, the dashboards are completely public. So if you use Pro, you can manage who can see the dashboards. Just a heads up.
Sounds good. All right. Well, thanks for moderating yet again, Steve. This video will be recorded and will be shared to our audience on social media in the next day or so. So thank you again.
Thanks.